So today we will see how can we solve quadratics when there might be some imaginary numbers involved. So here, the main idea here is that when solving quadratics, sometimes we can obtain solutions with imaginary numbers. So that's what we're going to be looking at today. So there's times when you're solving quadratics, you do the regular quadratic procedure, and you might obtain imaginary numbers. So let's take a look into some of those examples now. So now let's see here. Well, it says here that we need to solve the following equations, and we got to simplify our answers. All right, so here's a typical quadratic. Um, Now, what procedure do we take? Well, we see that it's only two terms on the left side, so we don't use factoring. What we can do is, because there's only one variable right here, so what we do here is we just isolate it. To do that, well, let's subtract 1. Now this cancels out. So now we obtain x squared equals 5 minus 1, so that's 4. And you got to remember that when we're solving for a quadratic and there's only one variable left, in order for us to eliminate this second exponent, we take the square root to both sides. So that way, the square root cancels out with the second exponent. So now we have that x is equal to the square root of 4, where the square root of 4 is just 2. But be careful here, your answer is not just 2. Because when you're solving for quadratic, and if your last step is to take the square root, you just don't have 2, but you have plus or minus 2. So you got two solutions in this case, where here the solutions is when x is equal to positive 2 and when x is equal to negative 2. This is what we mean by plus or minus. It's just we don't want to write the same, x equals 2, x minus 2, so we just simplify this. So this is our answer, well, which is pretty much the same. This is the same, it's just notation here. All right, perfect. So now let's look at example B now. And we'll take a look at example C in a second. So let's concentrate on B right now here. So if we look at example B, we can see the following. We want to solve this. So, and again, you just look into it. You see that there's only one variable right here. So let's just isolate it. To do that, you subtract 2. So now we're going to have x squared equals negative 2 and negative 2. So that's negative 4. And again, you're going to take the square root because you want to eliminate the second exponent. So square root on the left, square root on the right. Now, the second exponent cancels out with the x. So now we have x is equal to, be careful here, because here we take in the square root of negative 4. We know the square root of 4, positive 4, is 2. But the square root of negative 4 is not 2. And we just discussed on the previous lesson that when you take the square root of a negative number, this is when the imaginary comes in. So we got I square root of 4. And, well, let me rewrite that. Plus or minus I square root of 4. Because again, if you're taking the square root of a negative, you can take out the negative outside as if it was an imaginary concept here. And now, well, what is the square root of positive 4? Well, we know that that is 2. So now this becomes x equals plus or minus I2, which it just doesn't look fine. So we're going to rewrite this as plus or minus 2i. So look at the difference between example A and example B. So let me put them aside. Let me put them one next to each other so you can notice the difference here. So the procedure is the same, but notice that the difference is right here in this line. Here we take in the square root of positive 4, and that's when you can just write down plus or minus 2. But here we take in the square root of negative 4. And when you take the square root of a negative number, you need to take an I outside because that's an indicator that you're working with imaginary numbers, which some people call it complex as well. and you just take the I, and now you just worry about the number, which is still negative. It's square root of 4, and we know the square root of 4 is 2. Technically, this is fine, but we usually put the coefficient in front of the I, so that's 2I. All right, let's look at one more example here. Let's look at example C. Again, you see that there's only one variable right here, so let's isolate it. To do that, let's take the square root of 3. So x squared is equal to, what is this, negative 10? Perfect. And again, you want to solve for x, so let's just take the square root right here. Cancel, cancel. So now we have that x is equal to the square root of negative 10. And again, notice that you're taking the square root of a negative. We know that when we take the square root of a negative, I can take it out as an I, and now deal with the square root of 10. All right, so now let's pause here for a second. Well, I'm sorry, and I keep doing this plenty of times. It's plus or minus I square root of 10. Don't forget the plus or minus, because when you're solving for quadratic, if your last step is to take the square root, then it's a plus or minus here, because we have two answers, one positive, one negative. So now notice what we have here is I square root of 10. Do we know the square root of 10? No, we don't know the square root of 10. Can we simplify the square root of 10? Nope, we don't. So this is where we stop. So this means that x is equals to plus or minus square root of 10 I. Let me rewrite this. And again, we don't do anything with the square root because square 10 is not a square number. We cannot simplify that number, so we're just going to leave it as that, the square root of 10. But we still going to have that I. You usually put it at the end because you put the coefficient in front of the variable. So here's your entrance ticket. Solve the following equations and simplify your answers when possible. My mistake, I feel like I skipped one example here. Yes, we skip example D. All right, so we're not there. We're not done yet. So let's see, example D here. So let's take a look into this. Now notice that this is a little bit more complex in the sense that we have a coefficient in front of the x squared. So what do we do in those cases? Well, we first want to isolate the whole term here. So in order for us to isolate the term, we're going to add 2. That cancels out. So now we have 3x squared is equal to, well, negative 7 plus 2, that is 5. All right, so do we take the square root right here? Is it okay for us to take the square root right here? No, it's not okay for us to take the square root right here. Because before we take the square root, we need to make sure that the x squared is isolated. So in order for us to isolate the square, we're going to divide it by 3 first. You divide it by 3. So now you have x squared equals 5 divided by 3. Now that the x squared is by itself, I'm sorry, negative 7 plus 2, this is negative 5, 3. Negative 5, so this is negative 5, 3. All right, so we're back now. All right, so let's take the square root. Take the square root right here. Take the square root right here. This way, second exponent cancels out. So now we have x equals the square root of negative 5/3. We see that we have a negative inside of the square root. So let's just take it out as an I. So we have an I square root of 5/3. Now we notice that neither 5 or neither 3, it's a perfect square. So we're just going to leave it as this, the square root of 5/3. So this is your answer right here. All right, perfect. So now it is time. Now this is your entrance ticket. Make sure you solve the following equations and make sure you simplify your answers.